This is the equation of a straight line graph. We're going to be looking at the parts that you see here in detail so that we understand them. But first, I want to have a look at a graphing package I got. Here we go. Let's see what happens when we change things. Now, you got y is equal to mx plus c. Now let's put some values in here. X, by the way, is the bottom axis, is the number you put in. M, now suppose I were to have that say is 3/4. Move that across there, and we made C 2. Alright, this part here is positive. That's positive, so the graph goes up. What happens when I change the value of C? Well, oh, wait a minute, let me label this one first. There's that one. Let's make C a bit less, this constant at the end here. Y equals 3/4 of x. Now I'm going to do plus 1. So you can see that I've reduced this bit here, the 2, into 1. So what happens? Notice that it's parallel to the blue. The red is parallel to the blue. The reason it's parallel is because this number here is the same as that number there. As soon as you have that condition, they have the same slope, just that they may start in a different position. Now this one here, 2, notice the blue line crosses at y is equal to 2. The red line crosses at y is equal to 1. The 1 is this value here. So that number is where it crosses the y-axis. That number there is where the blue crosses the y-axis. So if I have this equation here, but I put a 5, we would expect the line to cross at that point. So let's have a look at that, shall we? Let's go here. Y equals 3/4 times x plus 5. So the line should go through the y-axis at y equals 5. And it does, look. So now you understand what happens with this constant here. X, of course, is just the value we put in. If we put in 5, it comes up here, we go across, and we get the value that we're looking for in the y-axis. If we put in x is equal to 2, which is that point there, we come up, if we're using the red line, stop there, we turn round, come across to the y-axis, and that's the value for when x is equal to 2. This is a straight line equation. If you're doing GCSE, you may get something that's different. Just going to show you, we're not going to look at it in detail. Just going to show you. Let's get rid of these, shall we? Y equals, I'm going to keep it very basic, x squared. See, it's not a straight line anymore. It's like a horseshoe. It's called a quadratic, but we will not be looking at that in this video at all. That's the equation. If we had, how can I do this? Let me draw a bit there. That is along, like the x-axis. That is the up. Now, if along is 1 and up is 2, then m is equal to 2. It is the amount of up for one along. If, let's get rid of that, if again the amount along was 1, it's always 1, and up is a half, then m is a half. If x is 1, the along is 1, and the up is 15, not to scale, then m is 15. It is the change in the y-axis for one along on the x-axis. Now this is the thing, if we have one along and we go down 15, that's 1, this becomes negative. You'll understand why in a bit, right? We'll be looking at that. It is the change m equal to the change in the y-axis, or the y value. So it now begs the question, how determine the change? Now when we have a graph, we have the x-axis and we have the y-axis. People always call them x and y, they don't have to be, could be other things. We always read the horizontal axis left to right. So this, if you have a value here, I'm going to call that the last value, and this one here I'm going to call the first value. The change is last minus first. Now that's the change in the x-axis. Let's look at a few examples of this. Okay, x-axis, y-axis, and I'm going to pick on points there, which I'm going to call 3, and this point here, which I'm going to call 26, and we would have our graph. It doesn't matter where the line goes, right? It's there. So the change in the x-axis is the last minus the first. We always read in this direction here. So this one is the first, that's the last. Last is 26. There's your minus. The first in this case is 3. So the change is equal to 26 remove 3, which is equal to 23. So the distance from there to there, according to the scale of this axis, is 23. The distance from there to there is 23. So we have, with our little along and up, this distance here on the x is 23. In this case, from there to there is 23. Draw the line up. Now if I come up here, all these numbers are made up as you go along, not to scale. And we come across, let's move that y, shall we? That is your y-axis. This value here, I'm going to call 15. Doesn't matter that it's not to scale. And this one I'm going to call 102. So the difference for the x-axis is 26 minus 3. So a change in the y-axis again is the last minus the first, and we determine which is the last and first by looking at the x-axis. That is the first value for x, so that is the first value for y, so that is 15. Moving from left to right, that is the last value on the x, come up, come across, so that is the last value for the y, which was 102. Last value, first value, there's the first, there's your first value for the y. So this would equal 87, I think. 7, 5, 12, 90, 100, yeah, 87. So we got 23 along here, 23 along, and we've got 87 up. Okay, so that has sorted out the numbers we are using. But what we want is the amount of up, question mark, for one along. That's what we want. That's our target. That will give us the value of m. M would be whatever number that is. So I'm going to clear this bit away here and just focus on that. Let's change the colour, shall we? How does that show up? Oh, that's nice. Right. Now, using the principle of ratio but in fraction format, we've got m over 1. There's your 1, there's your m. Right? That's in fraction format. Now, that will be equivalent to, keeping the same ratio, those two are in ratio to each other, and it's the same ratio as these two in each other. So that is 87 over 23. You know, it's a bit like a half equals 2 over 4 equals 4 over 8. It's the same idea as that. That's what we're using here. That's what we're using here. That is a nice green, isn't it? Okay, so look. I want a 1 down here. We need that. So what I have to do, there's your 23, which is that one. Change the colour. I want to turn that into 1, so I divide it by itself. Okay. 87. Now, because I divided the bottom by 23, I have to also divide the top by 23. That would give me, and change the colour again. How does this show up? Not very different, is it? Let's do a blue. Yeah. Alright, so look. There's your equals. Let's convert it to decimal, shall we? I lost it. Come on, come back. Thank you. We want 23 divided by 3 would give me 1 down there. 23 divided by itself gives you 1. Now we want 87 divided by 23. So we have 87 divided 23. We'll probably have to round off the fraction, the decimal. Whoa, that's a lot of numbers. How should we round it off? Let's do 3 decimal places. Look, there's 1, 2, 3. So the cut-off is between the 2 and the 6. Now, because the 6 matches 5 or greater, we round up the 2. So it becomes 3.783. 3.783. Now that is the rounded number. So that is the gradient. That is the value of m. m equals 3.783. Now because we rounded it, it's approximate. It is not precise. If you want the precise bit, you have to write it as the fraction form. So that is the gradient. M, in this case, is 3.783. Now, how do we use that? We've worked out the gradient in that we have, come on, thank you, one along, it's always one along, 3.782. Now that's approximate, right? Suppose our graph is such that we want to know how much that has gone up from where it crosses the x-axis, the y-axis. So we start from there. It has gone up that amount, and if we go along there, say 4, we've got 4 lots of up. We have 1, 2, I'm going to run out of space, 3, let's do one down here. So we got 1, 2, 3, 4 of those. That's what this means. We've got 1, 2, 3, 4 of those. Oh, and we want that height there. Each one of these is 3.782, and we got 4 of them. 1, 2, 3, 4. So the total up is 1, 2, 3, 4 of that. It's meant to be an 8. So the total up in this case, let's take that back to the fraction format. Will it go back to the fraction? Yeah, that's an exact value. That's an exact value of this here. If you want the decimal, we go like that. There's your decimal. But we got 4 of them. So we quite simply go that number there times 4. So the total up is that, and I'm going to round it off to 3 decimal places. 1, 2, 3. Now the number to the right of the cutoff, that's the cutoff, is less than 5. So we do not change the 0. 15,130. So this up here is 15.130, which is this bit here. Okay, so that is 15.130. Now the thing is, that is not the total distance. If I take a measurement line out there, that is not actually the value of y. It is the amount of up it's gone from that point. So we need to add to it that bit. From there to there. We got from there to there. That's what this is. But we need to add to it. And that is your C value. Now suppose, for example, we have that as, I don't know, set C equals 3. So the distance from there to to there is 3. The distance from there to there is that. All not to scale. Definitely not to scale. So the total distance is from there to there. We add them together. So if that is 3, we have the 3 plus the 15.130 approximately. Now if you like, you can put zeros in there. You put as many zeros as you like to the right of the decimal point. It will not change that value. So 0 plus 0 is 0. 3 plus 0 is 3. 1 plus 0 is 1. 5 plus 3 is 8. And 1. So the total distance for y is 18.130 approximately, because we've rounded it off. See, the amount of up is important. The up is your gradient, your slope. 1 along 3.783 equals m. Value of m when this is 1. Let's take another look at this, but this time the line is going to go down. Okay, here's the graph. Let's put it up here, shall we? When the thing works. I'm going to go like that. In fact, I'll take that across there. Now the line goes down, and I'm going to go like that. Let's make that value there. What should we make it? Let's make it 5. So this is your x-axis, that's your y-axis. The line crosses the y-axis at y is equal to 5. Y is equal to 5. X at that point is 0. When x is 0, y is 5. Now I said that where it crosses the y-axis is the value of c. So that is 5. Proof, look, x is 0. So this value here, this value here, 0. 0 multiplying anything, no matter what that is, the whole of that will be 0. If that was 56 and you multiplied it by 0, the answer is 0. So this would disappear. And we only left with the value here of 5. So y would equal 5 in this case. When x is 0, it gives you the point or the value of y where the line crosses the y-axis. Suppose the slope is, now let's have a think about this. This is your line and it's going down. This is your x-axis. There. Doesn't matter what points we pick on. We'll always read the x-axis left to right. So that is the first value. And we're going to make this one here the last value of x. Suppose this was 2 and that was 6. The difference between the two is 6 removed 2. which in fact is 4. Now if I take that up there, it puts a point on the line. Take that up there, it puts a point on the line. The y-axis, there's the y-axis. Come along here, come along here. Now the first point, remember the slope is always last minus first. Right, that's your difference. So the last here comes up and goes there. That's the last point on how much. Oh, I can't move that across. Let's make that 7 and this 10, shall we? Okay, last. Here's the last value on the x-axis. Come up there, and we have 7. So that is the value of 7. There's a minus. It's always the last value. I got this wrong way around. Ah, did you spot it? Did you? He's wrong, he's wrong. Yes. Last value. Come up there. Is 7. Now it's correct. There's the minus. Always subtract the first from the last. First subtracted from the last. The first, there we go, up there, is 10. So what we're doing is we're subtracting a number that is greater than this one here. So that will give us, now doing this type of thing here, look, if we have 7 remove 10, I'm going to put a bracket around the 10. Now I can split the 10. I can split it into 7 and 3. Now, because the minus is there, in fact, both these are indeed minus. So let me just redraw that, shall I? I'll redraw that. There's the 7. Split the 10 into negative 7 and negative 3. Put those two together and you get negative 10. Right, so I've split that. That becomes 0, and all we're left with is negative 3. So this equals negative 3. Think about that. Negative numbers quite often confuse people, right? So we have for the slope, or m, or the slope is equal to the change in y. It's always y on top, change in x. Change in y is negative 3. Look, it's this value here is the last. Remove 10, negative 3. So that's your change in y. Change in x is the last minus the first. 6 remove 2 is 4. So the slope, in fact, is negative. When the line goes down, the slope is always negative. What's this actually saying here? This is saying that if we have, and I'll draw it this way, one along, we have 3/4 down. In fact, this here, I'm going to put a very pronounced line like that and fill it in like a fraction. This is the bottom number, that's the top number. What we're doing here, the 1 goes there, the 3/4 goes there, but it's negative. That may confuse you, but it is the way it is. It is the amount of change in the y for 1 along in the x. So that is your change in y, that is your change in x. But people don't bother to write that. They don't bother to write that. All they write is the negative 3/4. Let's do some. But to keep the video short, the examples are going to be in the next video, part 3.